Alright, so we're going to split up, but before we do, technically no homework due today, right? Technically. Tomorrow is going to be a bunch of stuff. Your laser cut part, homework 6. Your squared and drilled and reamed block, that's homework 13. Your sheet metal box, that's quiz 4. And homework 14, which I'm going to assign today. And don't forget about your SolidWorks project. It's due end of next week. By now you should have most, if not all, the parts built. You should have a sub-assembly. You should have a final assembly. You should have drawings for your parts. You should have a lot of that in progress and going. SolidCam, don't forget about that project. That's also due. You should be dividing labor. You should probably have measured a bunch of components. Probably should have some modeled already, if not fully modeled, started, because you're going to have to start building these as soon as today. In fact, we should start seeing you building some of those as soon as today. I'm going to assign a couple more things. I guess I could talk about that later, or I'll just say it now and remind you. Assigned today is also the CNC bed mill video on YouTube, and the SolidWorks tutorial lofts, and the SolidCam jumpstart videos 3 and 4, which are from the jumpstart series here. Complete the part programming and simulate the tool path and generate the G code. And then I'll assign 14 later because you'll understand it better after the lecture. Any questions?
Which tutorial was it?
Lofts. Lofts. All right, let's split up. Take your team.
Who went first last time? A. So let's do B's first this time.
Bye.
Did everybody sign in with the sign-in sheet?
Make sure you get it on your way out.
Safety glasses, definitely. And
Okay, we're going to rock some more SolidCam here. By the end of today, in addition to your homework, you ought to be able to at least start programming on your parts that are what we're calling the base plate, which is clamped down to the mills. You may even be able to get started if you want to after Professor Hodgkinson's lectures today. So, and certainly by Friday. So keep that in mind, and you got a lot to do, so you might want to start getting going. All right, so I opened up this part, and since I've got a SolidCam enabled computer here, I have the tabs, and then it went ahead and it opened this dialog for me selecting the cam part, which means this was an internally defined SolidCam part. And if I want to get back to where I was, I have to double click this. It's gonna you got to give it a second. It's gonna open SolidCam, which will run in this environment. Wait a second, you'll see the SolidCam interface. So it found a cam part in my temp folder. I can continue with the temp folder version, or continue with the version that was stored internally to the part. I'll go with that. All right, now let's take a look at where we're at. So if I look, I've got my regular SolidWorks tab, so that has my part, the way I've made it. And I go to my SolidCam tab. Where we were yesterday was in cam part definition. So if you see here, I've got this part, I've got the machine selected, I've got some form of coordinate system, and did we get to stock and target? I don't think we did. So let's go ahead and go back into this interface. So let's go to Coordinate System Manager, open, and we'll edit it just to remind us of where we were. I'm going to come back to that coordinate system in a minute. Okay. I kind of don't want to jump around here, so I'm gonna finish as if we were finishing yesterday, and then I'm gonna go into more detail here. I've gone into the coordinate system manager. Things I want you to notice is machine coordinate system is 1. I'll be talking about that later. It's critically important, especially for you guys, because you have multiple pieces on each machine. Vail has 3, copper has 2. So it's important here. All right, let's say I was happy with that. We'll come back to it. Got my coordinate system down here. Go to your stock. Okay, now SolidCam assumed that my stock was exactly the same size as my plate. Is that going to be true? No. You probably would have used what tool to start your stock for this particular piece? It's about 80 thousandths thick aluminum. What would I have done to start this piece? Bandsaw? Which one? Probably the vertical bandsaw. I would have found a sheet of aluminum bigger than this and bandsawed it out. Would I bandsaw it exactly that length? No, because I can't keep the bandsaw perfectly parallel and straight, and it's got rough edges when it's done. So we want to bandsaw it bigger than this piece. So what you should do is bandsaw it and then measure what you have left. So I probably would have bandsawed this and tried to leave at least a 1/16 on each side. So I'm going to, over in my, now this is kind of tricky too. See how it says solid? It seems like it's selected, but it's not really selected because you can't see the check mark to accept it. You actually, this is a quirk in SolidCam, sorry about this, but you actually have to go back, click the piece, and you'll notice that solid goes away. Still no accept mark. Then click the piece again. Solid shows up. Now there's an accept mark. Sorry about that, but that's just a quirk. Now I want to expand my box that it dropped in for me. So on the X direction, this direction, on the plus side, I'm going to go another 1/16 of an inch, 0.625. Did you see how it opened it up? On the minus side, 0.625, and this is an absolute value. So the parity, the plus and minus sign, is already inferred by the parameter box. You'll see it opened that up. Also wanted a 1/16 on the Y, both directions, but not on the Z, because the Z is, I'm just going to use the material that I had, the material thickness I had. Okay, now you can also hit this button that adds the box to the CAD model. That'll take this box and drop it in as real geometry, and then you can select it. That's kind of useful. So I'm going to go ahead and accept this. That set up my stock. You also have to set up your target, and what this is you're trying to tell SolidCAM what you want your final product to be, and it uses that to guess what you want in certain toolpaths. So let's go ahead and either double click or right click define. Just like the stock, see how I'm not accepted? It's got the solid, but I've got to click it once, it disappears. I've got to click it again, it turns pink. The solid shows up, and I've got an accept. So go ahead and accept that. And then you're done defining your part. Now, I want to go back and edit how I want to define my part. If you'll notice, my coordinate system is just kind of in space here. I like my coordinate system to be defined off my stock. Okay? And the reason is I've got this part clamped into my machine. Let's say in your, oh no, oh no, oh no. Oh no. Do we dare do something in Paint? Is this going to work? This could be a total fail here, but let's try. So your part, that's your finished part, right? But what you really have in your stock is this. Especially if you're Mujahid, right? It's not fair though. His bandsaw blade was dull. Okay, you probably really do have something resembling that, right? And then you're going to trim away all this stuff with your toolpaths. Okay? So what I like to do is I like to set my coordinate system somewhere in the upper left-hand corner. You can pick any corner you want, but what I like to do is use a drill bit, a small drill bit, anywhere between 0.010 of an inch and 1/8 of an inch, as a pointer, just as a pointer. And then I like to go hover over the middle of this kind of goofy line. So I kind of hover over this point, and Professor Hodgkinson will probably show you this today. Hover somewhere over that point as good as I can see with this sharp point. And then I like to hover over the middle of this one for the y-axis as good as I can see. So when I'm hovering here, I want to look down this axis so that I can line up this point with that line. And when I'm hovering here, I want to look down this axis so I can line that point up with that edge. Okay? Once I've done that, oh no, no. It freaks SolidWorks out if you open two of them. Once I've done that, so let's say I wanted to hover my drill point here and here. Okay, then if I set this as 0 and I set this as 0, then my coordinate system will be up in this corner. Okay, so that's typically what I like to do, because it's very hard to set the zeros on the theoretical intersection of these two lines right there, because you don't really know where that is on your part. Where you do know is you know where this is and you know where that is, because you can take a small drill point, hover over that, and define it that way. So in order for that to work, I need to redefine this coordinate system. So I'm going to go to Coordinate System Manager, open it, edit it. I'm going to go to Edit Coordinate System. I'm going to select the face, click this face, and then I want to pick my origin. All right. Now, look again. SolidWorks guesses this kind of box around the target, the piece that it thinks you want to make. But that's why we added the stock box to the CAD model. Here's that stock box. And I want to go ahead and put my coordinate system on the top of that box right there, with my x-axis, that's red, you can see from SolidWorks, aligned with this edge. My y-axis aligned with this edge. My z-axis pointing normal to how I've clamped it down. So I like that right there. If I didn't like the way it was oriented, I could flip around certain axes until I did like the way it was oriented. Okay? But all I care about is that my x is lined up here, my y is lined up here, and my z is lined up normal to the face. Don't worry which direction like the x line is pointed left. Don't worry about that. It could be pointed left or right as long as it's aligned with this edge. Same thing goes with the y. Don't worry about that either. All right, so now I'm going to accept that. And say it's okay. And accept that. So looking at this part here, I'm looking at it in this particular way, but in reality, my 0, 0 is here. So you could set your piece in the machine like this and have your 0, 0 be in the bottom right-hand corner. You could put it up here, you could put it here, you could put it here. Doesn't really matter. Okay? What does matter is that it's aligned with this stock so that you can use that little drill bit to point to that. Now, in the case where you're not bandsawing a piece out, let's say this piece existed already, a machinist cut it and made it nice and smooth edges here, but he forgot to put the holes in, or he forgot to put the pockets in. In that case, this edge is already machined and accurate. So you need to put dowel pins here or here to align this piece perfectly with the movement of the table travel, either in X or in Y. Then clamp this down, and then you need to create a coordinate system somewhere on here, but it can't be on this imaginary stock line because you're not going to trim that away. It needs to be somewhere on this piece. So in that case, I would probably make it on the intersection of these two legs. Okay, and you could do that by putting a three-dimensional sketch with a point that intersects at those two places, right? Couldn't I do this? Oh, maybe you want a two-dimensional sketch. It's not aligning for me. Well, fine then. Don't do that. We could extend these lines in our sketch. We could put a two-dimensional sketch, or I forgot about this. When we edit our coordinate system, if we select this face, remember SolidWorks puts this imaginary box in here. We can now select our coordinate system right there, which would be the intersection of these two lines. Now, if I did do that, can I use my little take a drill bit and hover over the edge trick to find my 0 for this edge and 0 for this edge? Why not? No, I could still hover over this edge and look at it. And I could hover over this edge and look at it, and that would put me up in this corner. Why can't I use that? No, I'm hovering the drill bit just barely over the top of the part, like that. Why is that no bueno? You're just eyeballing it. So you're introducing error on your perception of your sight. Okay? What should I use to find this edge? An edge finder. Wow. So you would edge find this edge. You've been shown how to do that, right? And you would edge find this edge, set this as X, set that as Y. So when do we use an edge finder? When we're trying to set up coordinate systems. Right. When you have a smooth surface that's been machined and it's accurate. When you don't have a smooth surface and it's not accurate and it hasn't been machined, just go ahead and use a drill bit, because the offset of your eyes should not exceed this little gap here. Now, if you don't trust yourself, or you're working really fast and you're not taking care, you may exceed this 1/16 of an inch in error, right? What would be a way to mitigate that? Make the stock bigger. If you don't trust yourself and you're not going to take care in doing this, instead of a 1/16 of an inch, maybe you could cut it 1/8 of an inch bigger here, or a 1/4 inch. Now don't get crazy, then you're just wasting material and costing time, but maybe you want to cut this a little bit bigger and make sure, absolutely sure, that you're going to get this piece out of there. Okay? Cool. Any questions so far? In SolidCam, you have to set this stuff up first, or you're going to have problems. That's your machine, your coordinate system, your stock, and your target. Okay, let's go back into this coordinate system manager. I want to edit it as if we were just starting, and I want to discuss some finer points of this data. This is an important screen here. Okay, the first box that's very important, especially to you guys, is the coordinate system number. Now, like I said, I'm not going to go to paint this time, although that worked out. So in SolidCam, it's got the machine coordinate system number, and it says 1. Well, on the machines in G code, on almost every machine out there, don't ask me why, it's just the way they wrote the language, machine coordinate system 1, or the default machine coordinate system number when you fire up the machine, is G54. Okay? Then if you go to coordinate system 2, it's G55, 3, G56, and so on. And I believe my controller supports like maybe 6 or 7 coordinate systems. Okay, so let's say you're on copper. One of you guys has a plate here, one has a plate here, and one has a plate here. Okay? One of you is going to want to be G54. Oh, this is a fail here. One of you is going to want to be G55. And one of you is going to want to be G56. Or you can pick other numbers. But what matters is you've got to be distinct numbers. Now, what's going to happen is guys on G54 are going to select a coordinate system. And they're going to set their zeros under G54. On G55, these guys are going to select another coordinate system and zero their edges on G55. And then these guys will select another coordinate system on G56. I just picked different corners because who knows what you guys are going to do. The problem you're going to run into is if guys set number 1 set their zeros here and guys number 2 roll in and forget to change their work coordinate system to G55, they're going to overwrite these guys' zeros. Then these guys, let's see, which guys? Oh yeah, these guys are going to come in the next day, try and run a program, and it's going to try and machine over here because these guys overwrote these zeros in G54. So it's very important, especially for this class, because you have multiple pieces set up, that you inspect on the machine what coordinate system the machine is in at the time, and then go back and bounce that up with your SolidWorks and make sure this machine coordinate system is correct. So if you guys are G55, you need to make sure this is the number 2. Okay? All right. These are also important too. The tool start level for every given tool path, and you might write multiple tool paths, the tool is going to theoretically go up to its home position. You're going to change it. And then at the very start of a tool path, it's going to come to the tool start level. That's what that is. Now let's say it's a drill bit and you're going to drill 4 holes, just like on this part. It's going to move to the first hole and it's going to rapid to the clearance level, which in this case is 1 inch. So it started at 5 inches above the part. It's going to rapid to 1 inch above the part, and it's going to drill the hole. Then it's going to go to the next hole. It's going to go up to the clearance level and then move to the next hole. Up to the clearance level, next hole, clearance level, next hole, back to home position. Okay? So the tool start level is only used at the start of a tool path. The clearance level will be used as many times as you have geometry. Now, these are global parameters. You can reset these within each tool path that we're going to write, but these are global parameters. So in each of your tool paths, if you want something larger than this, it won't work. So you need to set your global parameters large enough that it's going to work for you. Okay? On the big bed mills, I like to set these at 5 inches. And those bed mills have, depending on the tool you put in there, they have about 11 to 15 inches of vertical travel. Who's on Wolf Creek? In the corner.
What's Aaron's?
Not here? That machine only has a few inches of travel. So setting a global parameter of a tool start level of 5 inches above the part is not going to work. The machine physically cannot get there because it doesn't have that much Z travel. So you're going to have to lower this down. Okay? Another issue. Let's look at your part from the side. So let's say your part looks like this from the side. And let's say you have some clamps on it. Okay? If I have a tool and he drills a, let's see, I'm going to put a clamp right here, which would, signify, let's say there was a clamp here, here, and here. All right, so you get what I'm doing here. This is that third one. If I drill a hole right here with my drill bit, let's do this cool. Let's make it a drill bit. If I drill a hole there with my drill bit and my tool clearance level isn't high enough, when it jumps up and tries to go over to this hole, let's say this dimension right here, or that clamp was 1.2 inches above the surface, but my clearance level was only 1. My drill bit's going to jump up to 1, and it's going to wrap it over and slam into this clamp and break the drill bit in order to drill that second hole. Does that make sense? So you need to make sure that your clearance level is going to get up above your clamps before it goes over to the next part. That's a very common mistake, and it's called a crash, because if you slam into that and the tool's big enough, it can knock the head out of alignment on the machine. Okay, so you need to set these properly. If I was on those two big bed mills, I would set them at 5 inches. There's pretty much no chance that I'm going to have clamps on this particular piece that are going to be taller than 5 inches. Okay, so that's pretty safe. If you're on Wolf Creek, you're going to have to do something lower than that, maybe 2 inches, maybe 2.5 or 3. All right, the part upper level. You can set whatever you want, but for safety, if you want to be pretty safe with your tool paths, the safe assumption is to call the top of your part 0. And that way, anything above the part is positive numbers, which is good, it's safe. Down into the part is negative numbers, bad, dangerous. Okay? You can change that if you'd like, but be careful with that. It's best to set your absolute coordinate frame with your z-axis as 0 on the top, which makes your part lower level. SolidCam already guessed based on the thickness of this piece, but if you wanted to change it, you could click part lower level, and you could turn it upside down, click the bottom, and it'll drop that number in. You could also hard code that number if you want to. Don't worry about this box. That's for machines with tool changers. I don't have one, so don't worry about it. Are there any questions here? You have to set this up properly before you start machining. The correct coordinate system and clearance levels that are going to get you over your clamps when you move from tool path to tool path. Any questions there? Okay. We have a coordinate system. We have stock. We have a target. We have the correct machine. So it's going to translate everything we write into the proper G code. So we are good to go. We can. Yep.
When you say the stock parameters,
yep.
That stock is kind of the bandsaw, so it's not always the same distance.
That's right.
Sure.
You measure approximately. So yeah, so you throw a tape measure on there and get as close as you can by reading. With a tape measure, you ought to be able to get within 20 or 30 thousandths. So be accurate with your stock. Throw a tape measure or some calipers on there. Try and if you cut it really wavy, try not to do that first of all. But if you did cut it really wavy, try and average out the wave when you measure. Try and get an average for that wave. Or if you want to be super safe, measure the thinnest portion of that wave and make that your stock. Okay? Now, I should probably assign you guys work coordinate systems, but not everybody's here. How many groups do we have here? Show me one group. That's you guys. What machine are you on? Okay, copper.
Yeah, the one that had that the grad suit was also.
Yeah, so why don't you guys go with Now that grad student's going to cause a problem too, because if he jumps in there, he's not going to remember the work coordinate systems. So let's use a work coordinate system that he wouldn't be using. So why don't we use like G56 for you guys? Are you on copper?
We're on copper.
You're on copper as well? So let's use G57. So you're 56 or 57. Who's on Vail? You are. So let's use G55. Who else is on Vail? G56. And are you a third group?
Yes.
G57. And then nobody's on Wolf Creek in here?
I think that's Aaron's group.
Okay. So on Wolf Creek, that controller does not support multiple coordinate systems. It only has one. So you need to be in G54. It only has one. Just so you guys know. Okay, so that's assigned. All right. Before you go to writing toolpaths, you need to have a plan. And you need to have a plan for the clamps. That's the most important part. Okay? So if I was going to machine this part out of this rough stock, somebody come up with a plan for me. What makes the most sense? What should I do first? Cut the outside shape? You could. So the problem with the outside is I can't cut all this. I can't cut all the way around here because I've got to hold this down. I'm going to have clamps in here, right? What I like to do, so if you want to be efficient, what I like to do, remember I am going to use a little drill bit as a pointer to set my zeros. So I've already got a drill bit in the machine, right? Maybe I go ahead and drill these holes first. So if this were me, I would probably have clamps in the corners, 4 clamps in the corners right here. That would allow me to drill these holes without interfering with the clamp, right? So as long as I start high enough up here, I can drill a hole, move over, drill a hole, move over, drill a hole, move over, drill a hole, and not interfere with these clamps. Then I could change to an end mill and machine out these pockets, still with those 4 corners. All right. Then I'm going to have to stop and change my clamps around. There's no way I'm going to get around this whole thing without changing my clamps around. So a common technique that we like to use for square parts is we like to put a clamp in from the side here, maybe go in here, and a clamp in from the side here, maybe go in here, and we machine off this side, and that way I won't interfere with these clamps. 1, 2, and I can machine this side and this side. Now it's important that you not put the clamp right there and right there. Why? You won't be supporting these sides. These are going to flap. So you don't really care if these 2 sides are supported all that well, but we want them supported near where the end mill is. But you don't want to get too close either, because then the end mill or its tool holder might hit the clamps. Okay? So you need to be a little cognizant of that. All right, so we'll put a clamp here and here, and we'll machine these, and then we'll move the clamps and machine these final 2 sides. So always come up with a plan for machining before you start writing the toolpaths. Make sure you can move clamps around. Now, if I have 4 clamps here, and then I'm going to change to end mills and put 2 clamps in, should I remove all 4 clamps and then put 2 clamps in? Why not?
Displace your object.
The object might move on me, right? Really, you shouldn't even leave just only 1 on there, because then you can rotate. You should really leave 2 clamps on at all times. So you might consider taking this one off this corner and putting it right here, taking this one off this corner, putting it right here, and then you can remove your last two. Okay, questions on coming up with a plan before you start machining? All right, we're ready to start toolpaths. And what was the first toolpath we were going to start? Drilling. So we'll go to Operations. We'll right-click, Add Milling Operation, Drilling. Okay, this brings up this screen, and this is all the parameters that you can set in a toolpath. You can set your geometry, which is important. We have to tell it what holes are we going to drill. You have to set your tool. What tool are we going to use to drill those holes? You have to set our levels. How far are we going to drill up and deep and up and down? You have to set your technology, which is how are we going to move between holes. Motion control and miscellaneous parameters are not typically used, but I will show you a couple of items there. But these four are critical in every toolpath. All right, you can name this operation if you want. I tend not to. It'll drop in a default name. But this is kind of helpful if 2 or 3 people are working on a part. Then you can name it and say 4 drill holes. Then the guy that's looking at the toolpaths later says, oh, okay, I know what that is. But typically I don't name them. You can see your machine coordinate system here. And you have these 2 buttons, Edit or New Geometry. And then you have a list of geometries. The list is empty because we haven't selected any geometries. So we need to select geometry. So let's go ahead and hit New. You can see it brings this menu up. Now this menu is going to give you a bunch of options in which to select the geometry. Or you can just go and select it on the main screen. In this case, that's what I'll do because there's 4 points. But if I had 500 points, I don't want to click 500 times. So I could use these options to have the computer go through and say, select any circle that's about this diameter, and then it'll select all 500 of those points. But in this case, I'm just going to go ahead and select them because I only have 4. So I hover over the circle, carefully select. Oops. So what happened was I had multi-positions selected, and I hit the face, and it guessed where I wanted to go. Did it guess correctly? Looks like it.
So did you just click the face for that? Or
Yeah.
Did you click some?
Yeah. So let's do that over. Let's not accept that, and let's select geometry again, and then let's just hit pick position. Now the problem with that is, look what happened. I selected on the circle and it didn't select the center. So that's not good. We don't want that. I hit new. What if I hit circle arc centers? That's not liking it either. That's not liking it. Oh, then I hit this all circle arc centers and it got all those. But what if you had multiple diameters? You don't want to select all of those. So we don't want to do that either. I want to select just the circles, one at a time. Let's go CAD selection. That should do it. That's not doing it either. I wonder if our post processor is correct. I've got centroid. All right, here's what we're gonna do. We're gonna drop. We're gonna finish this drilling tool path, and I'm gonna show you where you can find the post processor, and we'll go from there. So let's go geometry for now. We'll keep the multi positions. Oh, now it's cooperating. Of course. So I selected that one circle, and there it put the point in. Let's select this circle. It put the point in. Of course it cooperates now. This circle drops the center point. This circle drops the center point. Now, one thing you want to make sure of is that you make sure you're on the center point. Sometimes you saw that if I selected the wrong reference, it would drill a point out on the circle. That's happened to some students before. Then your circles don't line up. All right. All we've done is selected our geometry. That's all we've done. So we accept that. Now we've got our geometry done. Let's go to Tool. Okay. It's waiting for you to select a tool. So you want to hit Select. We don't have any tools defined yet, so we're going to hit Add a Tool. What type of tool do we want? A drill bit. All right, now there's a lot of parameters you can put in here, and you can go through them. You don't need to put every single parameter in there, but there are some that matter. The critical one that matters is the diameter. So that's really important. We want the diameter that matches these holes over here. So you can go to evaluate and measure. I don't remember how big they are. So let's measure it. I must have two things selected. I just want this one. Diameter 1285. So we'll just put in 1285. Remember, my drill bits have a different angle to them than your standard 118. Anybody remember what that is? 135, and that helps center the drill bit. If I was worried about the drill walking when I hit, I should center drill this first in another operation and then come back with the drill bit. Okay, and you might need to do that in some cases. All right, that's about all I care about for the tool parameters. Now, if you put the rest of these parameters in, SolidCam will make a virtual representation of the drill bit. So if for some reason you really wanted a perfect representation, a perfect graphical representation of the drill bit and the tool holder, you can define the tool holder. You can do that. In most cases, you don't need to do that. The only time I really do that is if I'm going to get, if I think that tool holder is going to get really close to a clamp or really close to a feature in this part I'm building, and I want to see if it's going to hit. But I don't tend to do it because while this is running, you can just look at the part and see if it's going to hit. And if you think it's going to hit, you can stop the machine and you can move your clamps around. So I tend not to waste the time in dropping in all this other information that will just give me a graphical interface here. The 135 degree does matter because the program is going to use that to calculate how deep to go. I'll show you that in a minute. Okay, so diameter and angle are important. Go to Tool Data. Feed in XY. Now that's how fast the table is going to move in the X and Y axis. With a drill bit, do we care? No, if you're going to tap it, you're going to do it by hand. With the pecking, but what axis is the pecking on a drill bit? That's Z. So in X and Y, all that feed is how fast it's going to move from one hole to the other. And in that case, we can go as fast as we want because you're not cutting anything. You're just moving in air. All right? So I'm going to put 100 inches a minute. That's pretty fast, right? What about feed in Z? Does that matter?
Yeah.
Yes, because we're going to be drilling into the part. So we don't want to go too fast there. And remember, you have kind of a general formula for drilling into materials. You can use that formula as a basis point. In this case, with that small of a drill bit in aluminum, I think I'm going to go something like 5 inches a minute. You might check me with your little formula and see what you get. Another critical parameter is spindle speed, spin rate, spindle speed. You also have a formula to figure that out. I'm going to go ahead with something fairly fast because it's a soft material and a small diameter drill bit. I'm going to go with 3,000. You guys might check me with your formula and see what you get. Okay, those are important. Spindle speed, feed rates. We call that feeds and speeds. Last thing that you probably care about is coolant. Now on Wolf Creek, it does not have flood coolant, the one in the corner, but on the two bed types, it does have coolant. If you wanted coolant spraying on the drill bit, you would need to check flood coolant. That's about all that matters right here. Now, I want to show you one other thing that's critically important. That's the tool number. Tool number 1. Okay? That's going to become critically important later, so don't forget about tool number. Select. It says the selected coolant option is not supported by the controller. It actually is. That's okay. And now we're done with our tool definition. Any questions there? So again, we're writing our first drilling operation. Notice that it threw a default name in there, D-drill. You could put it in. You could put hard code your own name in there. And we've got geometry and we've got tool done. Then we have to move to levels and technology. But it's probably break time. Let me go check, see where Professor Hodgkinson is. If he wants to go a little over, we'll go a little over. So hold on a sec. Okay, we're going to go 5 more minutes. Let's go 5 more minutes and I'll extend the break. So in that 5 minutes, we can probably do levels. So let's go to levels. Now, here's where you're going to notice, remember when I was talking about those global parameters? Look at here, that start level is that global parameter 5 that I talked about. Notice it's grayed out. I cannot set this within a toolpath. That was set with that global parameter. If you want to change that, you have to go back and change it in that global parameter in the coordinate system manager. The clearance level defaulted to the global parameter that I put in the coordinate system manager, but you can change that. But you can't change it higher than the start level. So if you think you ever want a clearance level higher than the start level, you're going to have to go back and change the global parameter. I'm cool with this. My drill bit's going to start 5 inches above the part. It's going to drill my first hole, and then it's going to jump up to 5 inches above the part to go to the second hole. And I like that because I'll be sure to get over my clamps. Now, if you were a manufacturing engineer and you were programming this and you were going to make 5 million of these parts, time is money. So you don't want to jump higher up above the part when you're going to drill 20 million holes. So you'd want to make this as close as you could get and as fast as you could get without crashing. But we don't have that problem here. We're in school. We have all the time we want. So we'll be safer rather than efficient. Okay, safety distance. Now notice in SolidCam when you click a box, it shows a picture of what's going on. Sometimes they make sense and sometimes they don't. The safety distance is, so my tool started at 5 above the part. It rapided to over the hole. It rapided down to the clearance level, which actually is the same as the start level, so it didn't really go anywhere. And then it's going to rapid down to the safety distance. And the rapid speed on the mills over there is about 145 inches a minute. So it's going to go really, really fast to the safety distance, and then it's going to stop and go slower once it hits the safety distance, which is 0.1 above the part as a default. It's going to move at the feed rate that you set in this tool parameter, which we set at 5 inches a minute. So it's going to go and then start going 0.1 inches above the part. Now, that's not very far. 0.1 inches is this far, 2.5 millimeters. Okay, so if that's too scary for you, if it's going to move really fast and you don't think you can stop it before it's going to potentially hit the part, then you might want to increase the safety distance. Now I like to keep it at 0.1 because I don't want to spend all day. What if I set it at 5? It's going to go to 5 and it's going to move at 5 inches a minute to get down to the part. So it's going to take a whole minute to get down to that part. I don't want to do that. But so the 0.1 is a good safety distance for me. But I also am standing there holding the knob that can adjust the speed slower or faster. So I will adjust the speed slower so that I'm not scared when it gets down to there. If you don't think you can handle that, maybe you ought to adjust your safety distance a little higher. Okay? But I'm going to leave that right now. Now my upper level is 1 or 0. That makes sense. My drill depth is all the way through the part. That makes sense. If I wanted to put a delta on that, I could put a delta either positive, which means a little bit less deep, or negative, which means a little bit more deep. A little more on that in a minute. Depth type. This goes by the cutter tip. So it's going to go 0.078 from the tip. Is that good? No, because if I've got my part, my drill tip is going to go right to there. And it's going to leave this little cone in the bottom, right? So what I really want to do is go to there. So I'm going to have to drill past the part. Okay? The way you do that is hit full diameter. And here is where it uses the angle of the tip to calculate how deep it's going to go. All right? So that angle, when you set it in your tool, is important. It needs to match the drill bit that you have. Otherwise, the calculation for that angle is going to be wrong. Now, for me, this isn't even good enough. This is theoretically going to put the shoulder of that drill bit right at the bottom of my material, but that's all theory. I want to make sure it gets through that part. So I'm going to put a delta in here. Now, that delta means it's going to drill into my aluminum table. Now, that's what it's there for, but let's not be drilling huge, deep holes into my table. Okay? We want to make sure it goes through that part, but we don't want to overdo it and drill monstrous holes in my table. I like about 0.02, 20,000ths of an inch. Now notice it said positive. That's this direction. That's not good. We want it to go farther through the part. Let's make it negative, and you can see it's negative, and it goes through the part negative. Questions there? So this is levels. You have to set quite a few things in levels. The next thing will be technology, and we've got our 5 minutes, so let's go over that next segment.